Hi, welcome back. In this video, we are going to be looking at solving problems using the central limit theorem. So we are going to be looking at sampling distributions. When we are looking at solving these problems, even though we're looking at using a sampling distribution, we are still going to use the same 6-step process that we have been using to solve problems using the normal distribution. So here's our first example. The average age of a vehicle registered in the US is 8 years or 96 months. Assume the standard deviation is 16 months. If a random sample of 36 vehicles is selected, find the probability that the mean of their age is between 90 and 100 months. So the first thing I need to do is interpret and define. So I've read it, I'm looking at the age of vehicles, and I'm going to be taking a sample of 36 vehicles. So I want to start out by defining my random variable x. This is not x bar. I'm not defining the mean. Right now, I'm just defining my random variable. So I am looking at the age of vehicles registered in the US. So the age of a vehicle registered in the US. And I am going to look at those units as months. So don't forget, when we define, we also want to use months. So I'm going to be looking at x as my random variable. So I'm going to be using x bar for my sampling distribution. I am going to pull a couple key values out of this problem. So they tell me that the mean of the average or the mean for the population is 96 months. The standard deviation is 16 months. And I know I have a sample size of 36 vehicles. So I'm just pulling that information. Some of that is going to be helpful for my parameters, but I'm also going to need that for my check process. So when I use the central limit theorem, I need to check to see that either the population is approximately normal or the sample size is greater than 30. There's no information in here about the population being normal. So that is not true, but that's okay because my sample size is 36 and that is greater than or equal to 30. So my x bar variable is approximately normal. Now, I wouldn't be able to use the normal distribution if I was looking at an individual car being selected because I'm not told that the population is normal. But because I'm not looking at that, I'm looking at a random sample of 36 cars and I'm looking at their mean age. I'm going to be able to use the normal model. Okay, so now I need to find my parameters. So I've got approximately normal. Now I need to find my parameters. So the parameters, what I'm going to be looking for will be, first of all, the mean of my sampling distribution and the standard deviation of my sampling distribution. The mean of the sampling distribution is equal to the mean of the population. So that's 96. The standard deviation of the sampling distribution is the standard deviation of the population divided by the square root of n. So that is 16 divided by the square root of 36. So I'm going to pull out my calculator. And I get 2.7 for my standard deviation. So I have my sample size, my mean, and my standard deviation for my central limit theorem for my sampling distribution. So I'm now looking at a sampling distribution. The next thing I need to do is draw my picture. So now, instead of this being a distribution of x's, this is now a distribution of x bars. So I say that x bar is approximately normal. The mean of this distribution is 96 and the standard deviation is 2.7. So I'm taking these two values and writing them here as I label. I'm going to label the middle of this 96, and I'm looking for the probability that the average for the 36 vehicles is between 90 and 100. So I will mark those on here. 100, 90. I'm going to calculate my z values to go along with this. And I am going to use my formula for calculating a z-score. So my z1 value should be x bar minus mu sub x bar divided by sigma sub x bar. That's my z formula. So for z1, it should be 90 minus 96 divided by 2.7. And for z2, that is 100 minus 96 divided by 2.7. So if I go to my calculator, 90 minus 96 divided by 2.7, I get negative 2.22. And 100 minus 96 divided by 2.7 gives me 1.48. So I am now looking for this area. So what I'm looking for is the probability that 90 is less than x bar is less than 100. And remember, we're looking at x bars, not x's. We need to be consistent there. We're looking at averages. Or the probability that negative 2.22 is less than z is less than 1.48. So I can do either of these on my calculator. I'm going from an x value to an area, so I'm going to be using the normal CDF. So that is normal CDF. I can either work in the x bar world or the z world, so that would be 90, 100, 96, 2.7. So on my calculator, normal CDF, 90, 100, 96, 2.7. That gives me 0.9176. So the last step of our process is that we need to translate this. So what does this mean in words? This means the probability that the mean age of 36 vehicles registered in the US is between 90 and 100 months, is about 91.8%. And there you have it. That's a full problem.